class. Today we're going over the 10.2 lesson plan. My twin brother is filming me. Is it going well, Doug?
Yeah.
All right, so 10.2, expected value, variance, and standard deviation. Expected value is the same thing as mean, and there's two symbols to indicate expected value or mean. You can either use the Greek letter mu, which looks like a little m, or you can use e of x. They mean exactly the same thing. Okay, so looking at my notes here, I have an example where we want to find the expected value for a PDF, which means probability density function or probability distribution function, over some interval a to b. So again, you have to have a PDF. Usually they'll give you the PDF, so you do not have to show it's a PDF. And as a review, to show something is a PDF, you have to show two conditions. Number one, f of x is greater than or equal to 0 for all x in the interval a to b. And you also have to show that the integral from a to b of f of x dx is equal to 1. So in this example, this will be a PDF. Okay, so the formula is, from the notes, e of x equals the integral from a to b of x times f of x dx. So that's the formula we use for expected value. And again, on the upcoming test, whenever that is, a couple of weeks maybe, you can use your notes, so you don't have to memorize any formulas. You do not have to memorize any formulas. I'm going to show you the formula right here. Above my index finger is the formula.
I think you have to go closer.
And there's my notes that I'm looking at. Okay. All right, so let's get back. Okay, so looking at the notes, I have the function given is 3 over 125 times x squared on the interval 0 to 5. And we're told it's a PDF, we want to find the expected value. So e of x is equal to the integral from 0 to 5 of x times 3 over 125 times x squared dx. So I brought out the constant factor of 3 over 125, and then it's going to be times the integral of from 0 to 5 of x cubed, because x times x squared is x cubed dx. And then we do the integration and the evaluation, and I think you can follow that pretty clearly, and the answer, as you can see, is 15/4. And notice 15/4 is somewhere inside that interval of 0 to 5, as it should be. Okay. So variance, the formula, as you can see in the notes, is the integral from a to b of x squared times f of x dx minus mu squared, where mu we just found, by the way, for this example is 15/4. So I'm using the second formula from the notes because it's the easier one. So always use the second formula, the one I just said, for variance. And standard deviation is just the square root of variance. And variance and standard deviation will always be a positive number. So from the above example, f of x equals 3 over 125 times x squared on 0 to 5. We're going to find the variance and standard deviation. And, the important thing is, to do the variance formula, you got to do the integral from a to b of x squared f of x dx. Do that integral. Then you subtract mu squared. So mu squared is not being integrated. It's just you subtract mu squared after you integrate. And I think you can follow that okay from the notes. And then the square root of that answer would be your standard deviation. Okay, on the second page of the notes, the first half of the notes is just a proof showing that the two formulas for variance are equivalent. So you do not have to know that proof. It's just there for fun. Okay. And then I give an example. Well, this will be the last thing I talk about for this lesson. The example reads, the lifetime of a certain plant species in days is given by the PDF. So we don't have to show. We do not have to show it's a PDF. We're told it's a PDF. So we can assume that's true. So f of x equals 1/100th times e to the negative x over 100 power. And then Note that k is really equal to negative 1 over 100. That's the number in front of x. So it matches the form above, which was f of x equals k e to the negative kx on 0 to infinity. And whenever you have that form, the expected value without any work at all is just 1 over k. So in our example, we have the lifespan of a certain plant species in days is given by the PDF, which I already said, on 0 to infinity. And the question is, what is the average plant expected to live? So that means we want to find the expected value. So because it's of that form, we know the expected value is 1 over k, where k is 1 over 100. So we have 1 over k equals 1 over 100th, and 1 divided by 1 over 100 is 100 days. So that would be our answer. Okay. And then it says also find the probability that x is greater than 100. So there's two ways you can do this. Very interesting. You could do it directly. Find the probability x is greater than 100 by integrating from 100 to infinity of your function. But if you want to avoid the improper integral, you can use the complement idea. Just go 1 minus the integral from 0 to 100 of that function. It's kind of like this. If I say the chance of rain is 70%, then by the complement idea, the chance of no rain is 1 minus 0.7, which is 0.3 or 30%. Okay, but you can do it either way. Okay, so now for the remaining time, I just want to talk about that homework problem I put on Learn. So the homework problem that you can see on Learn asks you to find the mean, variance, and standard deviation of the random variable x associated with the probability density function f of x equals 3/2 x to the 3/2 on the interval 0 to 1. So to find the mean, mu, or e of x, same thing, it's just going to be the integral from a to b of x times f of x dx. And that turns out to be the integral from 0 to 1 of x times 3/2 x to the 3/2 dx. And then that's going to be the same thing as pulling out the 3/2 times the integral 0 to 1 of x to the 5/2 dx. So some of you might wonder, where did x to the 5/2 come from? That came from multiplying x to the first times x to the 3/2. Same base, you add the exponents. 1 plus 3/2 is the same thing as saying 2/2 plus 3/2, which is 5/2. Okay, and then you know how to integrate that, and we get the answer of 3/7. Okay, one word of caution here. It turns out this problem, which I got from WebAssign, is actually not a PDF as advertised. So probably most of you got this problem wrong on WebAssign. So I wrote a note to myself, and at the end of the semester, I'm going to disregard this problem because it is not a PDF. It should be, because they tell you it is. This is just one of those rare mistakes. Because if it turns out if I integrate that function from 0 to 1, I do not get 1. So that's why probably all the answers are going to be wrong on your homework for this particular problem. So just move on. Don't worry about it. It's not your fault. And then, but otherwise the solution is valid form. If it were a PDF, this is the way you would do it. And then the variance and the standard deviation, I just used the formulas, and I think you can follow them okay. All right, so good luck everyone, and that concludes this video.